If a learner says, "I feel anxious before math," is that data? The way you categorize that statement reveals your scientific worldview. Within our field, this question highlights the divide between methodological behaviorism, conductismo metodológico, and radical behaviorism, conductismo radical. While public behavior and private events raise distinct measurement challenges, radical behaviorism refuses to exclude those private events from its scientific account. Thoughts and feelings are behaviors, not mystical causes. The experimental analysis of behavior, Análisis Experimental de la Conducta, or EAB, provides the scientific foundation for applied behavior analysis, Análisis Aplicado de la Conducta. EAB gives us a philosophy of lawful behavior, a method for determining what counts as data, a selectionist account of behavior change, a commitment to replication, and quantitative tools like the generalized matching law, Ley de Igualación Generalizada, for describing choice. Our initial definition of data determines our entire trajectory. It dictates whether ABA functions as a superficial collection of tricks or as a rigorous natural science. Behavior analysts view the world through 5 primary scientific assumptions. These pillars support the bridge between basic research and clinical practice. First is determinism, determinismo. We assume that behavior is lawful and occurs in relation to specific environmental variables. For example, when a tantrum reliably occurs upon the presentation of an academic demand, we look for the functional relationship rather than assuming the action was random. Second is empiricism, empirismo. Scientific claims must remain anchored in objective observation and measurement. Instead of relying on a teacher's feeling that a student is improving, we rely on frequency data of specific responses, like hand-raising or self-injury, to prove a change occurred. Third is parsimony, parsimonia. We prioritize simple, logical explanations before appealing to complex or abstract ones. Before diagnosing a student with a memory deficit, a parsimonious analyst first checks if the student was attending to the stimuli or if the reinforcement for the response was sufficient. Fourth is selectionism, seleccionismo. Consequences select behavior across time, at biological, individual, and cultural levels. A student raises their hand more frequently because that specific response has a historical record of producing attention or assistance. Fifth is pragmatism, pragmatismo. We evaluate our scientific explanations by how effectively they allow us to predict and influence behavior. A theory is only as good as its ability to produce meaningful, observable change in a learner's life. These 5 assumptions serve as active operational filters, ensuring every clinical intervention remains grounded in the realities of behavior and environment. Methodological behaviorism restricts the science of behavior to publicly observable events. Because private events like thoughts cannot be verified by a second observer, the methodological behaviorist generally excludes them from the scientific account, focusing exclusively on what can be detected by more than one person. Radical behaviorism, however, is thoroughgoing. It treats thoughts, feelings, and internal sensations as natural events. They are simply behavior occurring inside the skin, governed by the same functional principles as the behavior we see on the outside. A common misconception suggests that radical behaviorists ignore or deny internal events. In fact, the philosophy is called radical because it includes every instance of behavior, public and private, within a single natural science. Applying this to our math example, the methodological behaviorist measures task refusal and escape. The radical behaviorist measures those same public responses, but also includes the verbal behavior of saying, "I feel anxious," while searching for the history of reinforcement that maintains both the public and private responses. This approach prevents analysts from using private events as mentalistic stopping points. We never say behavior happened because a person wanted it. We look for the environmental variables that make that wanting and that behavior occur. The unifying mechanism for all behavior is selection by consequences, selección por consecuencias. This selection occurs across 3 distinct timelines. Level 1 is phylogeny, phylogenia, or species history. Survival consequences select for characteristics over evolutionary time. This includes unconditioned reflexes and biological preparedness, such as the sensory capacities that allow an organism to contact its environment. Level 2 is ontogeny, ontogenia. This is selection across the lifetime of the individual. Behavior changes because of direct contact with environmental consequences. When hand-raising produces a preferred outcome, the response is selected and becomes more probable in the future. Level 3 is culture, cultura, the selection of practices across groups. Social practices that benefit the group persist over time. Professional standards and clinical conventions are maintained when they produce effective, useful outcomes for the practitioners and the people they serve. These 3 levels of selection allow behavior analysts to explain the complexity of human action without ever needing to invent hypothetical inner agents or personality traits. A science only becomes cumulative through replication. We do not accept a discovery based on a single demonstration. We must see the effect repeated. Direct replication, replication directa, involves repeating the essential procedures of an experiment with high fidelity. This determines if the same basic pattern of results can be reliably reproduced. Systematic replication, replication systematica, involves repeating the finding while deliberately varying features like participants, settings, or responses. This tests the generality and identifies the boundary conditions of a functional relation. This systematic rigor is the difference between a collection of anecdotes and a reliable science. One study may be interesting. Replicated patterns become science. In ABA, this logic is built into our single-case experimental designs. Every time we introduce, withdraw, and reintroduce an intervention, we are engaging in the logic of prediction, verification, and replication. This commitment allows us to be certain that the behavior change we see is caused by our interventions rather than mere coincidence or unknown variables. In the laboratory, we study choice by observing how organisms allocate their responses between different options. The basic matching law predicts that the ratio of behavior between 2 alternatives will match the ratio of the reinforcement obtained from those alternatives. William Baum's 1974 paper introduced the generalized matching law, Ley de Igualación Generalizada. It serves as a quantitative descriptor of choice, helping us interpret data even when it deviates from simple matching. In a world of strict matching, the sensitivity to reinforcement, represented by the slope A, is exactly 1. The bias, represented by the intercept k, is 0. On a log ratio graph, this produces a perfect 45-degree line. Baum identified bias, SESCO, as a consistent preference for one alternative that reinforcement rates alone cannot explain. Bias, or log k, may reflect factors like response effort, a position preference for one button over another, or qualitative differences between reinforcers. The second deviation is undermatching, subigualación, which occurs when the slope A is less than 1. This indicates reduced sensitivity to differences in reinforcement. As a result, the organism's preference is less extreme than strict matching would predict, moving toward indifference. Consider 2 buttons. Button A pays twice as often as button B. If the learner responds slightly more on A, they are undermatching. If they favor A even when both buttons pay equally, they are exhibiting bias. Baum's contribution shows that these deviations are not experimental errors. They are mathematically predictable patterns that prove choice behavior remains lawful, even when it appears complex. These domains are fully interconnected. Behaviorism provides the philosophy, EAB provides the basic research, and ABA applies those principles to improve lives. EAB training ensures that analysts define behavior carefully, measure it repeatedly, and analyze the actual functional relations within the environment. It provides the quantitative laws necessary to understand patterns of response allocation and choice. An analyst grounded in EAB avoids blindly following clinical recipes. They ask the critical questions. What is the behavior? What functional relation is being tested? Has this effect been replicated? What do the patterns of allocation tell us about the current contingencies? This scientific discipline acts as an intellectual filter, protecting ABA from becoming a collection of unscientific techniques. AEC matters because ABA serves as the applied branch of a rigorous science, transcending the status of a mere collection of techniques. Its strength comes from a philosophy of lawful behavior, empirical measurement, parsimonious explanation, selection by consequences, replication, and quantitative descriptions of behavior-environment relations. To practice ABA well, we first have to think like behavior analysts. Concise. Remember these 5 core takeaways. First, behavior is lawful and selected by consequences. Second, radical behaviorism includes private events without treating them as mental causes. Third, selection operates across phylogeny, ontogeny, and culture. Fourth, replication turns individual demonstrations into cumulative science. And fifth, Baum's generalized matching law describes orderly patterns in choice, including bias and undermatching. So practice with these principles in mind.